All right, you did doozy problem number 1. Here's doozy problem number 2. Calculating equilibrium concentrations 2. Pause the movie for a second and read it, and come back. All right. We have reaction of the formation of gaseous hydrogen fluoride from hydrogen, which is diatomic, and fluorine, which is also diatomic, to make hydrogen fluoride. So that's HF, and we have to balance it out with a 2. Has an equilibrium constant of, so K equals 1.15 times 10 to the 2. At a certain temperature, in an experiment, 3 moles of each component were added to a 1.5 liter flask. Calculate the equilibrium concentrations of all species. Okay, so again, we're going to be talking about rice, R-I-C-E. We're told a number of moles and a volume, but now this is not 1. So the first thing we have to do is figure out the concentrations. At the moment, they're all equal. So that would be 3 moles per 1.5 liters. So that should be 2. Each of them at the moment is 2 molar. Okay, again, because we don't know what an ending equilibrium concentration is, we're going to need to use x's. However, we don't know which direction this will proceed, so we have to compare the Q with the K. Let's do that right here. The Q value is going to be HF squared, so 2 squared, over hydrogen, which is also 2, and fluorine, which is also 2. So again, 2 squared is 4, over 2 times 2 is 4, Q is 1. The K value is basically 115. Q is drastically less than K, so again, we're going to proceed from reactants toward products. So let's go ahead and do our setup here. If we're proceeding from reactants toward products, we're going to form hydrogen fluoride. We're going to use up hydrogen and fluorine. So I'm going to use up X amount of hydrogen and an equivalent amount of fluorine, but now we have a coefficient in our product. For every 1 hydrogen and 1 fluorine molecule that are used up, we're going to make 2 HF molecules. So we have to include the stoichiometry in our Bryce setup. Then my equilibrium expressions become 2 minus X, 2 minus X, and 2 plus 2X. Now I can set those equal to K and get my values. So my K expression is again concentration of HF squared over concentration of H2 and concentration of F2. And all that's equal to 115. So I'm going to use what I get from my ending values. So for HF, that's 2 plus 2X squared over 2 minus X squared, and that equals 115. Again, very carefully here, the HF itself is squared, but the H2 and the F2 both have the same value. So this really should be 2 minus X times 2 minus X, which is the same thing as squared. So just like I did before, I'm going to go ahead and go through and take the square root of everything. And that's going to leave me with 2 plus 2X over 2 minus X equals square root of 115 is 10.723. Going to cross multiply. So I'm going to end up with 2 plus 2X, I won't let myself mess it up this time, equals 21.447 minus 10.723X. Hopefully I didn't run off the paper there. Now I need to solve for x. Okay, that's what I end up with. And then I can divide 19.447 divided by 12.723. And I get x equals 1.528. I have to go back and plug that in with my expressions up here. 2 minus 1.528 for both of these. And then over here, 2 plus 2 times 1.528. So for the H2 and the F2, my concentration is 0.472. Should have left myself some more room here. And for the HF, I get 5.056 molar. So my actual answers, so we can actually see them, H2 equals F2, and those are both 0.472 molar, and then the HF is 5.056 molar. All right. There we go.